Your phone unlocks the instant it sees your face. Your camera knows that's a dog. Your bank flags a fraud in milliseconds. Nobody wrote rules for any of that. A machine learned it. And in the next few minutes, you'll see exactly how, built from a single, almost laughably simple idea. We're going to build something that can read this handwritten 3 from scratch. No code, no scary math, just one idea drawn out until it clicks. This is Glass Box, where we make the hardest ideas in AI feel obvious. Today's question: what is a neural network really? Here's the trouble. Writing rules works fine for simple things, but try to write the rules for what makes a 3 a 3. A loop up here, a curve down there, and instantly someone scribbles a 3 that breaks every rule you wrote. There are 1,000 ways to draw it. Rules can't keep up. We need a machine that learns the pattern on its own. So here's the plan in 5 steps. 1. A single neuron. 2. How neurons vote. 3. Stacking them into layers. 4. The knobs that let it learn. And 5. We watch the whole thing read a digit live. Part 1. The neuron, a tiny decision maker. Strip away the hype, and a neuron is almost embarrassingly simple. It takes in a few numbers and puts out just one. That's the whole job. Each input arrives with a weight, a number saying how much that input matters. The neuron multiplies every input by its weight, adds them all up, and that total decides how strongly it fires. Finally, a gentle squeeze, the activation, crushes that total into a clean answer between 0 and 1. How convinced the neuron is. And that is a complete neuron. So what is a weight? It's simply a number for how much an input counts. Turn it up, that input matters more. Turn it down, it barely registers. Make it negative, and the input actually argues against firing. Real example, like the sliders on a music mixing board, each one sets how loud one instrument is in the final mix. There's one more number, the bias. It's the neuron's eagerness, a built-in head start that makes it easier or harder to fire before any input arrives. Real example, like a hard-to-please friend who needs a lot of convincing to say yes versus an easygoing one who's already half-sold. Part 2. From one neuron to a team. One neuron is weak, but line up a whole row of them, each looking at the same picture with its own weights, and each one quietly becomes an expert at spotting one little thing. One fires for a loop at the top, another for a straight edge down the side, a third for a curve along the bottom. None of them sees the whole digit, each just votes on one tiny feature. Think of a committee of specialists. The shape expert, the edge expert, the curve expert, each one shouts how confident it is, and the final decision comes from combining all their votes. Part 3. Stacking layers, where it gets powerful. Now the real move. Take the votes from that first team and feed them in as the inputs to a second team. This second layer never sees pixels, it only sees the first layer's opinions. So a neuron in layer 2 can learn something like, if the loop detector and the bottom curve detector are both firing, that's probably the top of a 3. Small features combine into bigger ones. And here's the part that still feels like magic. Nobody tells those middle layers what to detect. They invent their own features purely from being corrected over and over. Stack a few layers, and simple votes turn into real recognition. Part 4. The knobs, how it actually learns. Now step back and count. Every connection between every neuron has its own weight. A small network has thousands of them, a big one, billions. Together, all those weights are the network's knowledge. Set them randomly, and the network is pure noise, it guesses garbage. Learning is nothing more than nudging every one of those knobs, a tiny bit at a time, until the guesses start coming out right. But how do you possibly nudge billions of knobs the right way? That's its own beautiful story, gradient descent, rolling downhill, and there's a whole video on it. For now, just hold on to this one line: learning is slowly tuning the knobs. That number each neuron outputs, between 0 and 1, has a name. The activation, how strongly it's firing. 0 means not me, 1 means absolutely yes. Real example, like a dimmer switch instead of a plain on-off light, a smooth measure of how convinced each neuron is. Part 5. Watch it work. Let's run one start to finish. We feed in the pixels of this handwritten 3, really just a grid of brightness numbers, 0 for black, 1 for bright white. Layer 1 lights up, edge and curve detectors, firing wherever they spot their pattern. Those activations pour into layer 2, which lights up its bigger feature detectors. And the final layer has 10 neurons, one for each digit, 0 through 9. Each one glows with how strongly the network believes the answer is that digit. The neuron for 3 blazes brightest of all. The network has read the digit, not from any rule we wrote, but because every knob was tuned until this just worked. So here's the whole picture. A neuron is a weighted vote with a bias and a squeeze. A layer is a team of them, each spotting a feature. Stack the layers, and small features combine into recognition. Everything the network truly knows lives in its weights, the knobs, and learning is just tuning them until the answers come out right. That is a neural network. But we skip the best part. How do you tune billions of knobs without trying random combinations forever? There's a beautifully simple trick. The network just feels which way is downhill and takes a tiny step toward less error again and again. That's the very next video, how AI learns by rolling downhill. If this finally made it click, subscribe so you don't miss it. This was Glass Box. See you in the next one.